Here's what everyone says. Pluto was too small, so scientists demoted it in 2006. Here's what's actually true. Size has nothing to do with it. Pluto could be twice as massive and still not be a planet. The real rule that disqualifies it is something almost nobody knows about. Pluto didn't fail anything. The definition of what counts as a planet changed. In 2006, astronomers established 3 specific criteria for planethood, and Pluto fails one of them. Not because of its size, but because of its location and what that means for gravitational dominance. Let's look at what actually happened and why the third rule changed everything. Before 2006, there was no official definition of a planet. The term was essentially, "I know it when I see it." Astronomers had been using the word for thousands of years without agreeing on what it actually meant in scientific terms. Imagine being a teacher in 1995. You're standing in front of a classroom, pointing at a poster of the 9 planets. A student asks, "Why is Pluto a planet, but that other icy thing isn't?" You have no answer. Not because you're unprepared, because science itself didn't have an answer. For 76 years, astronomers had been using the word planet without agreeing on what it meant. It was like calling something beautiful without ever defining beauty. This vagueness worked fine when we only knew about the classical planets visible to the naked eye. Mercury, Venus, Mars, Jupiter, Saturn. These were obviously planets. When Uranus was discovered in 1781 and Neptune in 1846, they fit the pattern. Big, round, orbiting the sun. No problem. And it worked fine, until everything changed in the 1990s. Pluto's discovery in 1930 seemed to fit the same pattern. It orbited beyond Neptune. It appeared to be a substantial body, and astronomers were expecting to find a 9th planet in that region. So Pluto got classified as a planet, and that's how it stayed for 76 years. But the problem started building in the 1990s. Astronomers began discovering other objects in the region beyond Neptune, a zone called the Kuiper Belt. This is a vast ring of icy bodies that formed 4.5 billion years ago during the early solar system. At first, these objects were small, no threat to Pluto's status. Then, in 2005, something happened that shattered the comfortable vagueness. Astronomers found Eris, a Kuiper Belt object roughly the same size as Pluto, orbiting even farther out. Suddenly, textbooks were wrong. Museum displays needed updating. But worse than that, the question became urgent. If Eris is a planet, then what about the dozens of other icy bodies we're about to discover? Are we going to add a new planet to the solar system every few years? Are we going to teach kids that the solar system has 50 planets? 100? The term planet was about to become meaningless. If Pluto is a planet, what about Eris? What about Haumea and Makemake, 2 other large Kuiper Belt objects discovered around the same time? The question became urgent. Textbooks needed updating. Museums needed accurate displays. The public needed a clear answer. And more importantly, science needed precision. The International Astronomical Union faced a choice. Either accept that we might have 50 or more planets as we kept discovering similar objects in the Kuiper Belt, or create a precise, testable definition that would work for any object we found, anywhere in the solar system or beyond. They chose precision. In August 2006, they gathered in Prague and voted on a formal definition. The goal wasn't to insult Pluto or to reduce the number of planets for convenience. The goal was to create a scientific standard that meant something, a definition you could measure, a rule you could apply consistently to any object. The IAU's decision established 3 specific criteria, and suddenly the word planet had scientific meaning. This is how science works. As our knowledge expands, our definitions need to become more precise. The periodic table wasn't always organized the way it is now. The definition of a species has evolved as we learned about genetics. Scientific categories get refined when new discoveries demand it. The Kuiper Belt demanded it. We needed to know: what separates a planet from the thousands of other objects orbiting the Sun? The answer came down to 3 rules. And here's the thing: most people get 2 of them right. It's the 3rd one that changes everything about how we understand our solar system. Most people have never even heard of it. The IAU's 2006 definition states that a planet must satisfy 3 criteria. Let's go through them. Rule 1. The object must orbit the Sun. This eliminates moons, which orbit planets instead of the Sun directly. Pluto passes this test easily. It orbits the Sun in a 248-year elliptical path that takes it from 30 to 49 astronomical units away from our star. Rule 2. The object must have enough mass for its gravity to pull it into a nearly round shape. This is called hydrostatic equilibrium. When an object reaches a certain mass, its own gravity becomes strong enough to overcome the structural strength of rock and ice, forcing the object into a sphere. Pluto passes this test too. It's roughly spherical, with a diameter of about 1,400 miles. Rule 3 is where everything changes. This is the one that actually matters, and it's the one almost nobody knows about. Rule 3. The object must have cleared the neighborhood around its orbit. See what happened? Rules 1 and 2, orbit and roundness, those are what most people think of as planetary. But Rule 3, that's the one nobody talks about. And it's the one that actually matters. Now, this might sound simple, but clearing the neighborhood doesn't mean what most people think. It's not about sweeping up every last bit of dust and rock. It's about something much more fundamental. Something that determines whether an object rules its region or just lives in it. A planet must be the gravitationally dominant object in its orbital zone. It either absorbs smaller objects through collisions, ejects them from the region entirely, or captures them as satellites. The key is dominance. And this is where Pluto's story gets interesting, because Pluto fails this test in a way that most people don't expect. Think of gravitational dominance like Thanos in Infinity War. He's the dominant force in his region of space. Everyone else either orbits his power, gets absorbed into his plan, or gets ejected. That's what a planet does in its orbital zone. It's the undisputed authority that controls everything around it. So, how much more massive does an object need to be to dominate its zone? The answer might surprise you. Let's look at Earth as an example. Earth hasn't literally cleared every object from its orbital path. Asteroids cross Earth's orbit regularly. But Earth is gravitationally dominant in its zone. It's 1.7 million times more massive than all the other objects in its orbital region combined. Neptune is 8,000 times more massive than everything in its zone. That's gravitational dominance, not just bigger, but the undisputed authority that controls everything around it. Now, here's where the numbers tell the real story. Earth is 1.7 million times more massive than everything in its orbital zone. Neptune is 8,000 times more massive than everything in its zone. So, what about Pluto? Pluto is only 0.07 times the mass of the objects in its zone. That's not just smaller, that's the opposite of dominance. Pluto was born in the wrong neighborhood. It formed in a region crowded with thousands of similar objects, all competing for the same space, the same resources. Pluto never had a chance to become a dominant force. It was always going to be one voice among many. Pluto is like a minor house in Game of Thrones, surrounded by other houses of equal power. It's not weak because of its size, it's weak because it's one player among many equals. No house rules that region. Before we reveal what this means for Pluto's status, drop a comment. What do you think actually disqualifies Pluto from being a planet? Size, distance, something else? Most people guess wrong. This is the crucial distinction. Size doesn't determine planetary status under the third criterion. Location and gravitational dominance do. If you took Pluto and moved it to Mercury's orbit, it would be a planet. It would be gravitationally dominant there. But in the Kuiper Belt, surrounded by thousands of similar objects, Pluto is not dominant. It's like the Matrix. Move Pluto to Mercury's orbit, and suddenly the rules change. In that reality, Pluto would be the dominant object. But in the Kuiper Belt reality, it's just one of thousands. Context determines everything. The same object can be a planet or not a planet, depending on where it is. So, what is Pluto if it's not a planet? The IAU created a new category, dwarf planet. A dwarf planet meets the first two criteria. It orbits the Sun, and it's round, but fails the third. It hasn't cleared its neighborhood. For 76 years, Pluto was pretending to be something it wasn't. The ninth planet, the odd one out, the small body that didn't quite fit the pattern. But in 2006, the IAU didn't demote Pluto. They freed it. This isn't a demotion, it's clarity. Pluto isn't a failed planet. It's a perfect dwarf planet, exactly what it should be, given where it is. Pluto finally got to be itself. Eris, Haumea, Makemake, and Ceres share Pluto's fate. They're all dwarf planets, all trapped in crowded regions where they could never dominate. The decision wasn't about size or distance. It was about applying consistent criteria based on orbital dynamics and gravitational physics. That's precision. Remember at the beginning when I said Pluto failed one rule? Now you know which one. And more importantly, you know why it matters. Here's the myth. Pluto was demoted because it's too small. Here's the truth. Pluto was reclassified because it's in the wrong neighborhood. Size has nothing to do with it. That's the real reason Pluto isn't a planet. And it's way more interesting than the myth everyone believes, because it reveals something fundamental about how our solar system actually works. Not through sentiment or history, but through physics. This is what Space Verum is about. We don't just tell you what NASA discovered, we show you why it matters. We break down the myths that stick around and reveal the science underneath. If you want to understand the real story behind the space discoveries everyone thinks they know, subscribe. Because the truth is always more interesting than the myth.